Alright, problem 10 says a particle moving on the x-axis so that the position for t greater than 0 is given by this equation. So this is our position function. Part A is asking us what time is the particle first at rest. So we need to remember from the past that a particle is at rest when the velocity is 0. So basically that's what we're trying to do, is figure out when the velocity of this object is 0. Well, we're not given an equation for velocity, but we know the position, and we know that velocity is the derivative of position. So if we take the derivative of this, we get negative sine of e to the square root of t times derivative of e to the power is just going to be e to that power, so e to the square root of t, times the derivative of the square root of t. Remember, that's just like t to the 1/2. So the derivative of that would be 1/2 t to the negative 1/2. Now we can kind of clean this up a little bit here. We end up with a negative out in front. We have the sine and the e to the t. All of that is up on top. I'm going to put the e to the square root of t first, times sine of e to the square root of t. Then we've got this 1/2, so the 2 ends up on bottom. T to the negative 1/2 just means we're going to have a square root of t on the bottom. So this is our velocity equation. We want to figure out when does it first hit 0. Well, we can graph it. So if we put that in for our y sub 1 in our calculator, we have negative e to the square root of x times sine of e to the square root of x divided by 2 square root of x. If we go ahead and take a look at that graph, it should look something like this. I have a window here where x goes from 0 to 10, y is going from negative 2 to 2. Because all that's important is after x is 0, remember t had to be greater than 0, we're trying to find out where this point is. So we're going to go ahead and trace, or calculate the 0 using second trace. So I'll show you what buttons I'm hitting here. So what we're going to hit here is second trace, and I want to calculate the 0. So I know it's right around there. My left bound, I'm going to go ahead and put in 1 because I know that's the left of my 0. Right bound, I'm going to make 2, enter, and then enter one more time. And our 0 is at 1.310. That's the first time that the velocity is 0, when t equals 1.310.